we want to talk about two kinds of errors. One possible error we could make is a systematic error, and then there are unavoidable errors. We'll talk about the difference. One of the typical systematic errors that gets made is you have two people doing this experiment, and one person releases the cart and another person does the timing. And the person who's doing the timing watches the person who's releasing the cart. Now the person releases the cart often without warning, and the person who's doing the timing naturally has a reaction time delay of maybe a couple tenths of a second. And this could be significant if the cart's only traveling for a second or two. A couple tenths of a second is a big error. So we have this reaction time delay at the start. Now that wouldn't be so bad if there was an equal reaction time delay at the end, but there isn't. What happens is the individual will anticipate at the end and actually hit the timer a little bit before the cart actually gets to the end. So instead of having a reaction time delay at the end that's equal to that at the start, we have an anticipation at the end that further shortens our delta t. And this is a very serious error because delta t gets you twice. How do we calculate the acceleration from the distance coasted from rest and the time interval delta t? Well, we divide the distance by the time interval and we get the average velocity. Then we use the average velocity to infer what the final velocity ought to be, and we take the difference between the initial and final velocity. Of course, the initial is 0, so the distance will just be equal to the final velocity. And then we divide that difference in velocities by delta t, using delta t again. So twice we divide by delta t. We divide the distance by delta t and then the velocity change by delta t. So that any error in delta t, any systematic error, is just going to get multiplied and cause serious problems with our final results. Recall that our final result expects a straight line graph, and we want to get the slope of that straight line graph. Now there's an unavoidable error source, the 0.03 second uncertainty of the computer timer, if we're using that, or an error due to just unavoidable human reactions, not systematic reaction time delays, but people aren't all that consistent. And if a person's doing the timing, we're going to have some errors. And we might ask how much effect that error has on the final result. The thing about unavoidable errors is they're going to be distributed randomly. They're not going to give us any kind of a systematic error like we would get from this reaction time shortening. And we'll see in a minute what that sort of error does, what each sort of error will do to our final analysis.